so another thing that the unit circle can really well explain is how to find ambiguous angles, otherwise known as angles that give the same value for sine, or maybe for cosine, or maybe for tangent. So just focusing on sine first, we'll notice that sine is given by the height of this point, right? This point A. The height of this point is sine theta. And so we'll notice that if we draw a horizontal line across that intersects with A, let me draw a better line than that. We'll notice that there's another point on the other side of the unit circle that has the same height, otherwise known as sine of theta. So we'll call this point B. Now notice that if we draw a line to the center of the origin, we'll have another angle here, and we can call this angle phi. So notice that sine of phi is equal to sine of theta. Now, how can we find out what this angle measurement of phi is? Now we can make another observation, which is that these two are a reflection of each other across the y-axis, right? That's pretty clear to see because they're the same height, so they must be a reflection. The unit circle, of course, is symmetrical. So now we can therefore observe that the angle from this line here to the other side of the x-axis is theta then, right? If it's a reflection. So therefore, this angle phi, since they're complementary angles, is phi is equal to 180 minus theta. So therefore, sine of, let's just call any angle, let's just call it A, is going to be equal to sine of 180 minus A. So finding a similar angle is just as simple as going 180 minus your angle theta. Okay, finding the value for cosine is very similar. We notice that the x component of A is the value of cosine of theta. So any point which falls on this vertical line passing through A must have the same x value, right? They all have the same value of x, which is equal to cosine of theta. So then the point down here with angle measure, let's call this one phi as well, it wraps all the way around the unit circle, must also have the same value. So cosine of theta is again equal to cosine of phi. Okay, so what can we observe to find what the value of phi must be? Well, we can observe that this is a reflection in the on the x-axis, right? So this angle from here to here is also going to be theta. So what does that tell us? And that tells us that phi goes all the way from 0 degrees all the way around to 360 minus this theta. So that tells us that therefore phi is going to be equal to, let me rewrite that. Phi is going to be equal to 360 minus theta. So then that tells us the cosine of theta is going to be equal to cosine of 360 degrees minus theta. Finally, we have finding ambiguous angles for tangent of theta. We have already found sine and cosine of theta. Now let's just make an observation. We already start with this angle theta here. If we move from, if we extend this line that we already have to the opposite side of the unit circle, we'll find that we have the exact same angle theta right here. And so what does that tell us? That tells us that on the other side we have this length, of course, if we remember this to be sine of theta, and this length to be cosine of theta. And this is true for all positions of this line. This line could extend over here, and we'd also find the exact same thing for the exact same angles, right? But instead, let's just look at this example. So now what we'll notice is that because the lines extend to the left in the opposite direction, the line extends to the left and downwards, we have opposite polarity for sine and cosine. Instead of being positive as it is in this quadrant, it's actually negative in this quadrant. So that means that we have this point, of course, being negative cosine theta, negative sine theta. But as we know, that means that we have, if we take tangent of theta here, that'll be equal to negative sine of theta over negative cosine of theta, which is equal to sine theta over cosine theta. But notice that these are the same things, right? So this means that we have the tangent of this angle here is the same thing as the tangent of this entire angle starting from over here. So what is exactly this angle? This angle would, of course, be this 180 degrees around the semicircle 180 degrees, right? Plus theta before. So that means that this angle would be 180 plus theta. So therefore, we have tangent of theta is also equal to tangent of 180 plus theta. And so that sums up all of our ambiguous angles.